Hello, in this video we will discuss the fourth part of the electronic voltmeter, and here we will give introduction to the basic circuits required to build that system. The first circuit is called the flip-flop, and its function is a memory circuit. This type of flip-flop is called positive edge triggered of the flip-flop. It's basically composed from 6 NAND gates bind to each other in the manner shown in this diagram. It has 4 inputs and 2 outputs. The name positive edge triggered means that this flip-flop will change its status in the beginning of each clock cycle. And the characteristic equation of that flip-flop is this, which is D is equal to Q. And that means the value of D will be equal to the value of Q at the beginning of the next clock cycle. When D is 0, Q will be 0 at the beginning of the next clock cycle. And when D is 1, Q will be 1 at the beginning of the next clock cycle. Now, the second basic circuit required to build the computer system is called the multiplexer. And here is an example of the multiplexer, which is called 2-to-1 multiplexer. It's basically composed from 2 AND gates, 1 inverter, and 1 OR gate, and they are all bind to each other in the manner shown in this diagram. It has 2 inputs, 1 selection line, and 1 output. The name 2-to-1 means that it has 2 inputs and 1 output, and by the use of the selection line, we will decide which input will pass its value to the output. The third basic circuit required to build the computer system is called the register. The register is a memory circuit, and this diagram is showing 4 bits register. The registers in general is composed from flip-flops, and here we will use 4 positive edge triggered D flip-flops. This register is composed, as we mentioned, from 4 D flip-flops. It has one 4 bits input port and one 4 bits output port. The clear, clock, and set are common to all the flip-flops, and they are all bind in the same manner as this diagram shows. The next part required to build the computer system is called the decoder. This diagram is showing 2 to 4 decoder. The function of the decoder is to select between multiple choices. This decoder is composed basically from 4 AND gates and 2 inverters, and all are bind to each other in the manner shown in this diagram. The truth table of the decoder is this. When both the selection lines are 0, NO will be 1, and when the first one is 0, the second one is 1, N1 will be 1, and when the first one is 1 and the second one is 0, N2 will be 1, and when both are 1, N3 will be 1. The next circuit which is required to build the computer system is called the multiplier. The multiplier is composed basically from a 1-bit multiplier circuit plus another circuit. In this diagram, we will discuss a 1-bit multiplier circuit, and this is a 3 by 3-bit multiplier circuit. It's basically composed from Nine AND gates bind to each other in the manner shown in this diagram. And this circuit is because each bit from the first number will be multiplied alone by the whole second number, and the results will be added to each other by the use of the adder circuit. The other part of the multiplier circuit is the adder. This diagram is showing the circuit of 2 bits adder. It's basically composed from 2 XOR gates, 2 AND gates, 1 OR gate. They are all connected to each other as this diagram shows. It has 3 input ports and 2 output ports. The first and the second ports is for the n bit of the first and the second number. The third one is the carry bit that resulted from the previous addition of n-1 bits of the two numbers. This port is for the bit of the result that resulted from the addition of the 3 bits, and this one is for the carry bit that resulted from the operation of the addition. The last part of the computer system required in the electronic voltmeter is called the register file. The register file is a memory circuit, and this diagram is showing 4 by 8 bits register file. It's basically composed from 4 8 bits register, 3 decoders, 8 AND gates, 2 OR gates. It has one 8-bit input port and 2 8-bit output ports, and multiple of single-bit control ports. The 8-bit input port is used to write a value composed from 8 bits with each clock cycle, and the output ports is used to read a value either from port A or from port B, and that value is composed from 8 bits. The register file that we want to use in our voltmeter is modified in the following manner. First, the decoder of writing is contracted into 2-to-1 decoder, so that we can write 8 bits value into the first or the second registers only. The second thing is that the third and the fourth registers are removed from our circuit, because the third location and the fourth location will be used to input an 8 bits value, which are E and P, and both are constants, and that will be explained later.